continuing our learning of TypeScript today. Yesterday we got through some basic stuff like what's TypeScript and we're using the TypeScript language documentation, and we got through the basics. So we're going through the types now, and then my order came for food and I had to stop. So here we are today, continuing that. Let me get set up here and make sure the streams are actually working. This always takes a second. You can see I'm still sick, which is pretty annoying, right? So, alright, we look connected, good, and I am actually, a couple of times I haven't turned on my microphone. That makes it a little hard, but looks like that's working now. So, hello everyone. I'm glad to be doing this again, even though I'm still a little bit sick, but I feel like I'm getting better. So let's just get right to it, shall we? I'm learning TypeScript because I think I'm going to need to use it for my job. Everyone else already knows it in the company, and I don't. But how hard can it be, right? It looks pretty easy so far. So let's continue. We had our gist that we were making, kind of like things I told myself that's like gotchas. So we need to use returns in JavaScript. I didn't know that. That was a little annoying. Otherwise, I think a function just returns undefined. Yeah, too bad, right? That's not what you want. And here's compiler options. I learned that like TypeScript is a lot more like turning on dials than it is like its own full language. So those are some options that I want to keep track of. And here are the types that we've run into so far: string, number, boolean, arrays. You say either like the type name and then bracket bracket, or you can do array. Oh, that's not right there. Let's fix that. It should say array. Yeah, let's put this in. It's just that it didn't format right. There we go. So you could either say string bracket bracket or array with angle bracket with the thing you're making an array of. Any object, so you kind of get to decompose it and say what it is. And there's promises. And then I also learned my favorite thing was that they have a nice syntax for lambda functions. I really like this one here where you could just kind of, you don't have to say function or anything. You don't even need parentheses around the parameter. And then you just use this equal, greater than, and then you get to use it, which is really cool. And I just realized that, yeah, it doesn't look like it doesn't, you don't need to say return either. So that's really cool. So how's everyone doing? You doing well? All right, let's continue. We are at optional properties for objects. That's where we're at. Oh, my God, you guys can't see what I was just typing, what I was pointing at. I was pointing at my gist. Sorry. There's, you guys like, say something. Just say like, what the fuck you talking about? I'm so sorry. I should also get the stream. Where's the chat? Is this it? Here we go. Nothing's good today, huh? Where should chat go? Here? Let's put it here. Okay, so that's what I was saying. I was saying that JavaScript needs a return type. It has compiler options. Here are the types that we've run into so far. And I really like this syntax for lambda functions. And now we're going to continue where we started, where we left off last time with objects. You know, you could kind of say what the object is by putting these braces, these curly braces in here. And then the type after the colon, just like you do with functions or whatever. And we did that last time. We're using TypeScript Playground to test our code. And here's me where I wrote like um, Tom is an object that is of this type, where it has a first name and an age. And then we say we're passing in a parameter p in this function print person that takes in a first name and an age, and then we're able to access it. And then when we change something that means like it doesn't work right, let's say that we pass in maybe we pass in something that doesn't have a first name, like how does this work? We do first name Tom, but then we have like weight. And here it says under errors. Do you see that? No. This is a bad place for chat because then you won't see errors. This reminds me of a meeting at work where we watched a 45-minute presentation for our CEO who forgot to share screen. That was fun. Why'd you sit around watching me do this? So that was 5 minutes, okay? 45 minutes is way worse. We didn't really start. Anyway, I'm so embarrassed. So what does it say? Object literal may only specify known properties, and weight does not exist in type first name age, right? So I can't. It's saying that I can't do that. So if I change this to age, and you're 100 years old, then the error goes away, and everyone's happy. I can even run this, and it says first name Tom, age equals 100 because of here. Now let us learn about optional properties. Object properties can also specify that some or all of their properties are optional. To do this, add a question mark after the property name. So, okay, question mark, last question mark. So now it's optional. You don't have to pass it in. So right now, if I do something like this, I do age, I take age out. This will give me an error. It says argument of type first name, that's our argument here, is not assignable to parameter of type. Here's our parameter, first name age number. Property age is missing in type but required, right? So now what it's saying is you put a question mark here and all is forgiven, and we don't have to pass it in. So we'll put it over here and we will say optional properties. Optional property. Actually, let's put it under objects. Optional property. And we just can copy this actually. Use question mark after, what do we call that? The key name? Parameter? Yeah, it's a parameter because you only say it inside of a function, right? No. I guess I'll just call it key name. Let's see what they said. To add this after the property name. Okay, we'll call it the property name. And then the example would be y question mark number. So yeah, there we go. We've learned optional properties. What did they do? First name, last name, print name, and then this is okay, and this is okay. In JavaScript, you access a property that doesn't exist. If you access a property that doesn't exist, you'll get a value undefined rather than a runtime error. Because of this, when you read from an optional property, you'll have to check for undefined before using it. All right, so now if I try to use age here, Does it say anything? It just ran. Oh. All right. Person.age. It's perfectly happy with that. Yeah, so what happens if I don't pass it then? It'll just say undefined here, right? How how do I make it check? In JavaScript, you'll get the undefined rather than a runtime error. Because of this, when you read from an optional, you have to check. Is possibly undefined. I guess maybe this playground doesn't have like strict checking set up. Does anyone know if there's like a way to tell it to be strict checking? Automatic acquisition of types. Oh, this is it. Here we go. tsconfig. Oh, it has strict in here. Strict, no, implicit, any. Strict null checks. Always strict. It seems like everything's very like. Is this it? It seems like this should all be on. I have no emit on error, target, strict. No implicit any, strict null checks. So I need no implicit any and strict null checks. That's what the book said. And I have those here. Whoa, where'd they go? Strict, no implicit any, strict null checks. Ah, here it goes. What is this? Interpret optional property types as written rather than adding undefined. Let's try those. I'll try turning this on. Let's see what happens. How do I... Oh, now I have to refresh. There's no error here. Well, that didn't help. And what was the other config? It was when functional parameter isn't read. That's good too. Uh, let's turn that on. I don't know what that is. Now let's go back. How do I go back? We could try doing this on the shell where we have a little bit more control perhaps. Because this guy's not very happy. Here we go. Yeah, but it still doesn't say anything. Let's read a little bit more and see what, maybe there's, no, it doesn't tell us anything. How odd. Alright, let's bring up our terminal and we'll type code into the compiler directly. Alright, here's our code. And we will write some code. We have hello.ts, so we'll write objdprop.ts. And in here, what do we want to do? We want to make a user. We want to make a function that takes in like, I don't know, print user. And it takes in a user. And let's not put even a type in here right now. We'll just do it like all easy mode. Console.log user. And we'll make a user, let user equals name. Oh yeah, name is special, so let's use something else. First name equals, no, it's not equals, it's colon, I think. Frank. And we'll have the age. I'll make Frank 30. Right? And now I can like tsc object prop. Okay, but we want to do strict. And we want to say, what was that emitter? Target ES 2015. It's called strict. And target should say target, not target equals. There we go. Parameter user has any type, so that's not good, right? And we see that here also, it says any type. So we'll make a type here and we'll say that it needs to have a first name, which is a string, and it needs to have an age, which is a number. There we go. So let's see if, oh, and then we should call the function. Print user, user. Print user. We'll make a user. Yeah, it's called user. That looks right, and we don't see any errors on the screen. Let's try compiling it. Now it compiles, right? I don't know how to run it. I guess I have to install Node. Do you guys do that kind of stuff? But anyway, at least we see the compiler error or not. Now the thing is, we want to pass in someone who has like no age. So we're gonna do, actually let me first like create a string here. Um, user is equal to user, and we'll say first name is equal to $, and we'll say age is equal to $, and in here we'll put in first name, and in here we'll put in age. Oh, sorry, this should be user.age, and this should be user.firstname. There we go. Alright, I'm not used to this language yet. Alright, so does that compile? That compiles. And now we want to screw this up. We want to like not pass an age. And now this gives us an error. It says is not assignable, right? So when I try to compile it, it says the same thing. Not assignable. But now if I change this age thing here to be optional. Jesus Christ, what is the point of you? Like, I literally made it optional. I'm using it and you don't even give me a warning. How is this helping me? Whoops. This is not a compiler thing. This is just saying like, what? Why is this one giving an error? Okay, hold on. What the fuck is going on here? So they have an object, first, last is optional. Now we're trying to use this last. Is it because we're trying to dereference it? That's why. So if I change it to here to uppercase, oh, age is a number, so that doesn't work. Aha, age is possibly undefined. It's just that when I make a string out of it, it doesn't care. So if I do, what the fuck? This one is going to give me, that one has the error, right? Age is possibly undefined. But if I just do user.age +1, does this, oh, it's just when I'm using it. But if I do this, it doesn't care. This is still dangerous, right? Because this is going to say undefined. So if I say age string and I do user.age, I have no error. Guys, this is tricky. Like, you could get in trouble here. It's only when you use the thing as in an operator that you get in trouble, like operator or. But apparently, with string interpolation, it doesn't consider it like a real function or something. That is tricky. Okay, well, at least we learned something, right? That that is a gotcha. I don't know if I should write it. Um, Using an optional property doesn't always give a warning. If you uh, use it in a function that I think if I use it in a function I get in trouble, right? Is there a min function? Math.min? Number or undefined is not assignable. I see. So, yeah, when you use it in a function, it's okay, but when you use it in this interpolation thing, it's not okay. All right. Well, that was kind of like a silly thing, right? This is why it takes me forever to learn anything because I kind of like to test stuff out. Where are we? Here we are. Ugh. Oh, you could also do a question mark. What does last object question mark? Is this basically writing the if statement? Let's try it. Why do they make me try everything? Why can't they just like do it? Tell me what is this thing doing? Okay. So, age question mark. What we want to do is we'll make I don't know, age plus 1. Sorry, it's a stupid thing. All right, let's just add this here. And it'll say undefined doesn't work. Can I just put a question mark here now? Oh. No, I don't understand. It's using functional if. No, but that's not functional if there. To fixed. To fixed. Number of fractional digits. Looks like we don't have, it's optional to say that. So here we go, right? I'm calling a function that exists on numbers. And now it says it possibly undefined. That's good. And now what I should be able to do is put a question mark here, right? Aha, now it's fine. So what's it going to print? It still prints undefined. This is just saying, whatever, I don't care. Just do it. Just assume it's a thing. This is bad advice. A safe alternative using modern JavaScript syntax. This is not safe if last is not, doesn't exist. It's going to be bad, right? It's going to say undefined. Why do you make me write bad code? All right, we kind of figured it out. I'll write this out too. Use like, I don't know, foo question mark on the variable to not check if it's undefined. I think that's what it means. Maybe I'm wrong. Please correct me if I'm wrong. But that's what just happened in my code, because it just basically said, I don't care. I'm just going to like do this and return undefined. Will return undefined. Oh, you guys don't see all of this again. I suck at this. I suck at this today. I'm so sorry. I think it's just like I'm sick still. So you see this here, right? Oh, this is all bad. So we don't really want to do this. If you do this, you're a bad coder. Don't use age question mark. Just check if it's like, check if it's actually undefined. So I guess you would do this, something like this. If p.age is equal to undefined. Oh, how do you do if statements like this? Then I guess I want to say not equal to. How do you do not equal to like this? Maybe it's a slash? Nope. You have not equal equal. Maybe that's the one they used. There we go. That's what it looked like. if it's not undefined and age is equal to p dot age. Maybe this is how you do it. If p dot age. How do you derefer? What the fuck? That not how you dereference stuff? It's how I did it here. Oh, if needs probably parentheses, right? There we go. I'm so bad at JavaScript. So now I can do age dot toFixed. Now I run it, and when it doesn't have it, here's our default age 10. Makes sense. And I'm assuming that JavaScript has conditional if, functional if, so that would look something like, I hope this works. Something like if it's not equal to undefined, then we use p.age, otherwise we use 10. Clear. Well, we'll make sure that this number actually exists. 100. Yeah, 100. You see, and now if I pass an age, then it's 20. All right. This, I think I would write it like this. It just looks better, right? I remember when JavaScript TS scene got hyped because a TypeScript scene got hyped because they now have null undefined coalescing question mark operator. Yeah, I don't get it. Union types, TypeScript's type system. Yeah, so it is kind of like, it's just like Rust, you know, you have the unwrapped sort of stuff, and a lot of people just like do stuff because they're lazy. Except in Rust, you would get an exception, right? And it would stop working. Whereas here, it's just like undefined. I'll just keep trying to run. That's not good. Union types. Oh, cool, cool, cool. Now we're getting into like more of this categoric type stuff, right? Categorical types. Union types allow you to build new types out of existing ones using a large variety of operators. Now that we know how to write a few types of type, to start combining them in interesting ways. I'm just trying to remember the syntax in Haskell and in Elixir for this. It's definitely not a single pipe, you know, it's like the or. Anyway, let's see, defining a unit type. Oh, my nose is getting so stuffed. I have like some menthol gum, maybe that'll help. Defining a union type, the first way to combine types you might see is a union type. A union type is a type formed from two or more other types representing values that may be any of those types. We refer to each one of these types as the union members. Let's write a function that can operate on strings or numbers. Alright, let's just try to write this because I don't know JavaScript either, so this is all learning for me. Function print ID, right? And it takes in an ID, which is, let's start by saying it's a string. And we do console.log. Here is your ID. Oh yeah, it has to be this stupid single tick. ID, and then we let ID is equal to this. All right. Now we try to run this, and it says here's your ID, this thing. And I guess I can also do this. Now we can run. Yeah. And now we want to make this say that it is either a string. All right, let's try to make this a number. Just to break it, and then we'll fix it. We are employee ID number 1. So obviously it says this doesn't work, and we have an error here. But now I'm saying, haha, it can be a string or a number. Now you shut up. So now I'm going to run this. And now here's your ID number 1. Yay. After watching your stream, I got courage to read documentation. Let's go. I think a lot of people love like YouTube to learn stuff or whatever, but I'm just such a I love to learn like every bit, and then when I'm done, I feel like, hey, I know it, you know? So usually like if I'm working with people, I take a little bit longer to learn something at first, but then like I really know it afterwards. So I like to read it. You see here, I like to play with it. And in the long run, you'll actually be better in some ways. There are people who are just so fast, they could just, they just use it because they like it. But for me, I want to enjoy my meal. You know what I mean? Because there's stuff to enjoy about every programming language. All right, so this is number or a string. It worked, and I could change this back to a string now, and this will work too. Perfect. Argument of type is not assignable. Right, so if I pass in an object instead, this one will fail. Argument of type ID string is not assignable to parameter of type string or number. So let's just guess what happens here. We could probably extend this and say objects with an ID type of string are allowed. And now, when I run this, I get, here is your ID object to object. Dang it, I guess it doesn't know how to print objects by default. I probably need to make, I'm guessing here, a toString sort of function for this object I have. Oh my god. Alright. But at least, at least it could sort of take it. I wonder if I made this a string like this, if it would change anything. Oh, look at that. ID object. Nope, that was not any better. Alright. Are you going to build on TypeScript? Well, I basically am going to start a job where I have to program in TypeScript, so I have to learn it, right? And I figured, even though I don't start yet, I don't want to show up the first. Can you imagine you show up the first day of work and everyone's like, okay, so here's the code. Take a look at these functions and try to understand this module. And you're like, right, here's the thing. I don't know TypeScript at all. I don't know this language. So do you have a good book for this? Yeah. So it's only because I know someone at the company, so they didn't give me the interview where can you show me coding in TypeScript? They just talk to me about algorithms and stuff, but I didn't have to code. And it just never came up, and they're like, here's our code. They just assumed I'll know the normie languages, I guess. But I don't know JavaScript really, and I Definitely, you can see I don't know TypeScript, so that's why I'm learning it. So yeah, I'm gonna build on it. Sure. Yeah, hey, you want to talk algorithms? Great. I know about two. So let's see. I know bubble sort, so that's pretty good. And I know Dijkstra's. Which one do you want to talk about? All right. Where are we? The separator of the unit members is allowed before the first element, so you could also write this. Oh, cool, cool, cool. That looks cool. I like that. I don't know if this editor in here has any hotkeys or anything. Is that how they did it? About whoops. Oh, they indented the parameter name, and then they indented one more time this, and then the closed paren goes all the way to the back. So it looks like this. Okay, so that's the JavaScript. What do you call it? Coding style. Why does it my nose clear up? I just put a whole bunch of menthol in. All right, so we did this. Great, 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 great. Working on union types, working with it. It's easy to provide a value matching a union type. Simply provide a type matching any of it. Yeah, we already did this, right? TypeScript will only allow an operation that is valid for every member of the union. Aha, yes. So here, the plus works for everyone, so we're happy, right? But like if I did something like ID dot, oh look at that, toString works. Oh, do you think that would fix my object problem? Let me try. Nope, still doesn't work. Can I add okay, I'm going off here now. No, no, no. Stay on target. Stay on target. Let's not do side stuff yet. So now if I do something like uh, to lower case, now this won't work because it's like it doesn't exist. Oh, it doesn't exist on lowercase does not exist on type number. Right. So that's the error it'll give you. The solution is to narrow the union with code, the same you would in JavaScript without type annotation. Narrowing occurs in TypeScript. Narrowing occurs when TypeScript can deduce a more specific type for value based on the structure of the code. For example, TypeScript knows that only a string value will have type of value string. What? If type of ID is equal to string, then console, then we could do this. Oh, I see. It knows it's going to look if we do this type of thing. I wonder how they did that. That's like runtime code. So it'd have to analyze the code here and say oh, they're doing type of first. That seems a little tricky, you know? Okay. So let's do this. Is there just JavaScript have a case statement? Switch. Switch expression case blah default. Okay. So I wonder if this works. Switch expression. So this would be ID. What's it called? Type of ID. Is that how they did it? Type of ID. And then we could match here. Case string. And then we'll do is this how you do it? Case number. What's it called? It was called toFixed. toFixed. I'm just, oh, it doesn't like this. But I just said case number. Case colon break. Oh, we're really dealing with C here. There we go. Thank you, Aber. Yeah, that is fun. Here we go. No, no, no. I actually really love it when people talk. Please, like, just say stuff. Send me your unhinged ideas. I'm all good with it. There we go. Okay. So this should work. I don't think it needs a break at the very end one, right? So now it's happy with all of these. Here's your ID, and we could also print a number. Okay, so what I've done is, you see, like, the first one, let's make the ID, like, we'll make it a little more obvious. So we're changing it to lowercase, right? So let's just make it all uppercase with a little lowercase here. And when I print this, it turned it lowercase, right? So we know that one worked. When we got an object, it goes into this one here. And then when we got a number, it went here and it turned into a fixed number without any decimal points. And we just got 29. So this works. That's cool, I guess. I would hate to have to write code like this. Like, you wouldn't want to build this in here. You'd want, like, a function that sort of, like, takes a trait, like an interface of some sort that you ascribe to the type. I hope something like that exists. But, yeah, I see what they're saying. I don't know how to put this in my gist. I guess I'll say, union types. I guess it's worth its own mention. You need to narrow a type when using functions that don't work on all of the types in the union. And then we could show our little example of narrowing. TypeScript. It's probably TS also, right? There we go. I think it was called narrowing. Members. Yeah, narrow occurs with the code. There we go. Is array. All right, I get the idea. I won't have to. Well, it's a nice function to have, I guess, noted in case we need to use that. Okay. Notice that in the else branch, we don't need anything special. If the x wasn't a string, then it must have been a string. If it wasn't an array string, then it must have been a string because it's this or that, right? So we know here that it's a string and not the array of strings. Sometimes you'll have a union where all the members have something in common. For example, both arrays and strings have a slice method. Yeah, like in other languages, you maybe have an interface that you're passing here, right? Like has sliceable or something like that. If every member in a union has a common property, you could use that property without narrowing. Obviously, we did that already. Oh, let's see. I think a chain. Wait, do I have your chat in here? Oh, I lost your chat. I'm so sorry. Here, let me fix it. I'm the worst streamer in the world, and I also lost myself. We got this. We'll eventually be a real streamer. Usually I'm not this bad. Really, I think it's just being sick. It's ridiculous, right? I'm not doing anything right. Well, at least the code I'm writing, like, I make sense to myself, you know? All right. What'd you say? I think a chain I think a chain of if statements that early return is a better example of narrowing because type of is also an object. Is it? Let's find let's So you're saying you like it better, like you don't like switching case because you'd rather have like if type of ID is this, then do that. Else if blah 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 blah. Why do you like that better? Oh, my array. Right? Uh-oh, let. Okay. All right. Uh let's talk about that in 1 second. Let me see what happens here. Object. Ha! Holy shit. It's like in a functional language, I would probably write something like a tuple of type of and is array. You know what I mean? And then I could just check like string comma like is array false whatever. But yeah, like you can't do that in here. So I see what you mean. An if statement would be you just be able to do if type of this, and you say else if is array, right? You don't. It doesn't need to all be using type of, whereas switch has to. So that is really, really, that's really good to know. All right. I think that's what we're saying here. Thank you for telling me that. That's really useful. That is annoying. Then again, I bet it doesn't come up that often in reality because like you really shouldn't be narrowing your type too often at runtime. You know what I mean? Like that's kind of it's kind of silly. But now I'm thinking about it, I do this in Elixir all the time, but we have guards so that our functions can basically say I take in like a string, I take in a number. So this is like different versions of the same function, you know? Anyway, I bet there's other ways to do it with something that's a little bit like traits or, interfaces. Type aliases. Okay, this was important. This is what I was waiting for because typing this every time would be a pain in the ass. We've been using object types and union types by writing them directly in type annotations. This is convenient, but it's common to want to use the same type more than once and refer to it by single name. A type alias is exactly that, a name for any type. A syntax for a type alias is, there we have a point, and then we use the point later on. All right, so let's do this here. I guess we're basically saying type ID, right? Is it like this or equals? It's probably equals. I'm guessing it's equals. Is a string or a number. And now we can say, let's just make it ID. Uh, Switch type of ID string. Yeah, I just like had bad code. I just wrote it here just to test. All right. Type ID. So now I could do let ID colon. Um, I bet I could do this also, right? And then I call print by ID. I pass it the ID. and these two will be compatible. Yeah, my ID, because this is probably just like it's gonna just change this to string and number. So I could either do this here or I could do this. And now there we go. We still run. And then as you hover around your variable, you'll see it has fewer and fewer options as you narrow. Really? Oh, right. You mean like the functions. It basically narrows down the functions you can call on it because it knows that this is a string. This all feels very hacky to me because it's like it's the IDE's using runtime shit to basically tell you what functions you could call, which is really odd to me. It really works the same. No, it doesn't work the same way as an Elixir. Yeah, you have to manually fork the head, except that it's. I guess everything boils down to this, right? But since there's no pattern matching, it feels like really ugly to basically say, hey, anything can happen in my code because I could do a if statement here and then I can have another if statement somewhere else. And you're like, what? How narrowed is my code right now? Is my thing right now? I guess that's not true. Right. So like, can it ever get too complicated? Like, if I do, just imagine I do if type of ID is equal to string, right? And then in here I do another if type of ID is equal to number. Does it actually know now? I don't know what things exist on both, right? Oh, look at what? Why is it not happy? ID dot to string. Oh, it, it knows that it's never. It actually checked that it's never because it can't be a string and a number. Huh. Interesting. And there's no nested types. Alright, maybe this is fine. I don't know. I still hate it. Whatever. Because at least in Elixir, it's the whole function is going to have that guard. So that anywhere you're working on that function, you're like, okay, I know this is the type. But here it's like, oh, in this if statement, it's this type. But over here, it's like any of the union type. You know what I mean? That feels ugly. And for the IDE to do this, it's using these things as type annotations, which is weird. All right, I'm like ranting. I start to believe that JavaScript wasn't the best choice as a base language for a type system. Well, the thing is, JavaScript's used so much. You just try to make it better. Just like Python, they've tried to make Python faster and faster, even though the language itself isn't sort of conceived to be fast, right? All right, notice that aliases are only aliases. Yeah, that's what I was testing earlier because it doesn't really matter that it says the same name. You could have two types. Like literally I could have type ID here and I could make another type called like foo here that's a number or a string, I'm guessing. And then here I could say this is a foo, and it's still happy to print out this ID because it's just aliasing. None of this really matters. Does it really matter? Okay. In other words, the code might look illegal, but it's okay to TypeScript because both types are aliases for the same type. I don't know what they're doing here. I don't really care. Interfaces. Here we go. I think this will be useful. No, actually, it doesn't look like it. What are they doing? An interface declaration is another way to name an object type. But I assume we could add functions? JavaScript has functions, classes, or objects or something? I don't understand what the difference here is between this and a type. Oh, differences. There we go. Let's just read it. So here we have a point. Well, let's just code. Let's just code it. Why not? So we have an interface type, interface point, right? Equals x, which is a number, and a y, which is a number. Oh, why are you not happy? Oh, it's just, it doesn't have equal because it's not an alias, I guess. And now I can make a point. Oh, I gotta make a function. This function print point. Okay, and then we're just going to we'll just call it point to string. We're gonna try to like make more like functions instead of like side effects. So we're just going to take the point here and return x is equal to point.x, y is equal to point.y. All right? And now we're going to make a point. What is my point with all of this? Right. Too much Nix coding. I'm Nix pilled. You know, like, some of you may be thinking like, oh God, like, why don't you copy the code? Why don't you whatever? It's just like, it just really helps even to do the boring stuff over and over and over when you're learning a language. So I just kind of like, I just try to change my mindset to be like, just enjoy the process, even if it's boring. Okay. Ah! Help? It probably will tell me later, right? Okay, that worked. And I did point to string. Should this... Oh! Remember here, JavaScript needs return. I hate that. There we oh there we go. So can I just like get rid of this return by using a lambda function? No. Haha. Seriously? Does this work? we got like we got something that looks like a real function now. I'm so happy. I think I'll try to stick. Should I stick with the syntax? I don't know. We'll see. Um, After you've dabbled in those well-designed non-mainstream languages like Elixir, OCaml, Haskell, Common Lisp, and friends, you find that mainstream ones are really lagging behind in some parts. For real. For real. But we make do, right? Like, we're getting closer to something that looks better. Why does a return irk me so much? Alright. Uh, because it should always return, right? Don't you want functions to be functions? You call it a function. You literally named it function. If you called it like procedure, then like I get it. You maybe don't return anything, right? But you called it a function. Functions return stuff. That's what they do. That's where it comes from. All right, let's figure out this interface thing. Just like example, TypeScript is only concerned with the structure of the value we pass to print coordinate. It only cares it has the expected properties. So what it's saying here is that I could pass in stuff that I don't declare as a point, and this will run also. It doesn't care uh, that I never called this a point. Differences. In many cases, you could choose between them freely. Almost all features. Okay. I wonder what the history on some of this stuff is. Someone probably made type and said, you know what? Like, interface is way better. Almost all features of an interface are available in type. Okay, so type is more global. The key distinction is that a type cannot be reopened to add new properties versus an interface which is always extendable. Oh, well then, that's even better, right? So basically, we can extend an existing interface to add stuff. So a bear has a name and has honey. Yep. Whereas an animal, oh, interface syntax was introduced at like 2016. Okay, I'm using 2015. So it has to be, or it has to be. Well, I don't know. I'm saying to export in 2015, so I don't know how that works. But yeah, together with class and other OOP syntax. Cool. All right, I don't know what this operator does, so whatever. Adding new fields to an existing interface. Interface window. Oh, we could just add something. What? Isn't this like, I don't understand this code because where is window coming from? We have no variable window here. See, like here we have bear. Okay, let's just copy this. Watch. This should compile, right? What? Oh, the fuck? They're just assuming that I can get a bear. Was it colon? Yeah. What's a bear? Is Winnie a bear? Alright, here we go. We have a bear. Right, and there's no errors. Just doesn't output anything. But then when I so the type defined at the top of the source file. Yeah, I don't know what's going on here. So this get bear didn't exist, but I get it. It's kind of like just give me a bear. But this is kind of weird because where did window come from? Oh, is window always available? It's like a I don't where does window come from? And why do I have oh, because source is being passed in here. Let's just make this a string to make it easier for us to call a function. Why does this work? Window is a browser thingy. Oh, it's an existing interface. Why doesn't it give me a warning saying that it's undefined? Doesn't that seem kind of bad? like, we're dealing with types here, and there's no type warning here. You'll learn more about these concepts in later chapters, so don't worry if you don't understand all of these right now. All I know is that this sucks. Like, this should never happen. So we'll make a book title, and we'll have a book author. And then we'll do, can I say book? Yeah. Right, if you made a new one, but isn't it kind of like chicken and egg problem? Because JavaScript's dynamic, it can create new stuff, so you can extend an interface that's not static. It's whenever you extend it, right? Maybe not. Still, I feel like it should tell me something. All right, so this works. So basically it's saying that book, I've updated the interface, so it has to have both. So if I try to make a book now, and I have a title, War of the World, and that's it. And then I call print book on my book, this will fail, right? Property author is missing in type. Yeah, cool. So it knows I had this thing here. So the ordering doesn't matter. Who wrote War of the Worlds? Orson something? H.G. Wells. I was going to say he did the movie Orson something, but H.G. Wells wrote it. Right? Interesting. So this, it doesn't matter what comes first. Hello? This thing got confused. There we go. It's not confused anymore. All right. Uh, let's just move on. Sorry, I'm being like sort of annoying. You learn more about these concepts. Prior to TypeScript version 4.2, the alias names may appear in error messages, sometimes in place of the equivalent anonymous type. Right, that's not cool. Well, I don't know. I like alias names because then it's like in your head you know what it means, but then yeah, maybe it's better to see what the full type is. Type aliases may not participate in declaration merging. Don't know that. Interfaces may only be used to declare the shapes of objects, not rename primitives. interface names will always appear in their original form in error messages. Ah, but only when they are used by name. Right, not when you just pass it, I guess. Using interfaces with extends can often be more performant for the compiler. I see. This seems like the cleanest way to do something, right? Alright, where were we? I don't think I would use types if I think I might do something like this. For the most part, you could choose based on personal preference, and TypeScript will tell you if it needs something to be the other kind of declaration. If you would like a heuristic, use interface until you need to use features from type. Well, what features from type do I need? They don't show any of that here, right? I guess there's type of or something. Type assertions. Sometimes you will have information. I think it's scary that you can trivially extend interfaces at any time in code and break previous stuff. That should not be that easy. Yeah, you mean like this part here, right? This is kind of scary. This isn't scary. You're just taking an interface and you're making a new interface that extends it. I'm totally fine with that. But this does seem a little like, what? Right? This is sketchy for sure. All right, let's have some more water. Type assertions. Sometimes you will have more information about the type of a value that TypeScript can't know about. For example, if you're using document get element by ID, TypeScript only knows that this will return some kind of HTML element. But you might know that your page will always have an HTML canvas element. Oh, listen, TypeScript dear, like I know what it is. Let me tell you what it is, okay? Love it. Love it. Just give it a type. What could go wrong? But I get it. Like you're trying to work with code that already exists. You can't make it use TypeScript, so sometimes you have to just do what you gotta do. I wonder what I would normally want to do here. I think I normally want to just like contain it, just like have an HTML canvas element that I could just wrap around it. Like wrapper HTML canvas element, whatever. All right, so you could use as to turn it into another type. So I'll call it. I'll just put this in here. Oh, what is this here? Like type annotation, type assertions are removed by the compiler and won't affect runtime behavior. You can also use angle bracket syntax, except if the code is a TSX file, which is equivalent. Oh, which one do you guys do? So type assertion, let's put that in here. Let's see if TS works. I'm assuming it does. I don't need to test this one because like really, I get it. It's pretty straightforward. Type assertions. There we go. I think the possibility to interop with every JS library is huge boon and a huge bane for TS. Yeah, right? They have to support so much hacky things because they want to make every JS library compatible. Yeah, I guess if you're mostly like using your own code, then true, it's a lot easier. But if you have to use a lot of other things, then it gets messy, right? It's like NIFs, right? What a native invocation of functions. What does NIF even stand for? Native implemented function. Oh, is it only an Erlang thing? What? Have I lived in Elixir so long that that's the only thing I know? What do you call native function? What if you're in like Python and you call C? What do you call that? Jesus Christ. I call everything NIFs. CFFI. Foreign function interface. C foreign function interface. All right. I learned something today. Wait, so other people don't say NIFs? Wow, I've been living in Elixir world too long. C function, C foreign function interface. I'll try to remember that. All right. That's so funny. I don't remember what I was doing. I don't remember what I was doing. TypeScript only allows type assertions which convert to a more specific or less specific version of a type. This rule prevents impossible coercions like as number. Okay, great. Good. Sometimes this rule can be too conservative and will disallow more complex coercions that might be valid. If this happens, you could use two assertions. First, oh my god. How many people write this? I bet people write this. Oh my god. Here we go. If you want to just yeet, there we go. Oh my god. That is the ugliest thing I've ever seen. Just make it a void pointer and then like, yeah, it's fine. Don't worry about it. Literal types. In addition to general types, string and number, we can refer to specific strings and numbers in type positions. What? Yeah, right? But I've been literally throwing up before, so not fun. Uh, we can refer to specific. Right. So it's like basically saying like, oh, instead of saying number, you want to say like, I take a range of numbers like 1 to 10, right? That's cool. One way you think about this is to consider how JavaScript comes up with different ways to declare a variable, both var and let. I don't know the difference between var and let. Is var like global variables or something? Allow for changing what is held inside the variable, and const does not. Okay, so const means immutable. I think I'm going to write this down because I don't know this and it's good to know. JavaScript stuff like that I should know. Var let const. This is immutable. Oh my eyes. What is this? No, we're not reading this. You guys want to read French? Oh my god, why is everything... Okay, this is like regular. The scope is one of the following in the curly brace. Okay, good. Oh, I've got to see, sorry. Function scoped or globally scoped variable. Yeah. I don't know how to say this, like regular scope rules. All right. Um, here is for literals. Here's the literal. Because changing string can represent any possible string, that is how TypeScript describes it in the type system. Const. Oh. Oh, cool. So you could use literals in the type description, which means I could just do something like type. Why is it giving me an error? Book titles. I think it was equals, right? And I could give it like or Hunger Games. And now in here, I could say this, right? The top property of title is incompatible, right? Book. Why? Shouldn't that work? When I run it? Oh, I guess it's not printing anything. Yeah, so it worked, but it's not happy. What happened here? Title, book names. Title, what? Print book. Title string is not assignable to parameter type book. So it's not happy with this being a book. Oh, wait. No, that should be fine. What happened here? Why? Now it's happy. What did I change? Did I just change? Why is it happy now? What did I just change? I moved. Wait, what did I do? Oh, here, book. That's what I changed. So over here, it's still unhappy. Yeah, it doesn't know that this is a book. So type inference fails here. I think TS thinks this is a string and not the constant now. Right. But if I do this, now we're happy. So this kind of feels like a sucky type inferencing problem, but we figured it out. I don't remember what I was testing. Oh yeah, I was testing if now if I try to change this, if I do a typo here, this is a failure. Yeah. Did you mean? Oh, did you mean War of the Worlds? It's doing some kind of like, what is that called? The fuzzy string checks. There's like a fancy name for that. Great. We get it. It's not much use to have a variable. Well, by combining literals into units, you could express a more useful concept. Right. I think we kind of did some of this already, except we made a type for this. I'm pretty sure you are deeper into the type system than most of you React devs will get right. Now, yeah, I'm not a front end developer. I don't know React. I don't know Angular. I don't know Vue. If I did a front end tool, you know what sounds kind of cool is Svelte? I don't know. I don't know why. I know nothing about it. I just read it at some point. I was like, oh, this is something I would do. But I don't, every time, React, I don't even know what it looks like. Where can I see what React code looks like? Why are we, Jesus, here. Well, this doesn't look like anything. Is it in source? React component state render. Oh, it's kind of like you got to give like here's an interface, I guess. Oh, it's a class. And I guess there's probably like things like state, event handlers, and a renderer that you need to know about. All right, yeah, this is like already annoying me. All right, back to TypeScript. Doesn't this feel better? This feels better than React to me. All that like implementing, like I didn't even see anything here that said like I'm implementing that function. You know, like in Elixir, you say like implements or like whatever, just to give it like an idea of what interface or um, callback you're implementing. Okay, where are we? We're here. Numerical literal types work the same way, I'm sure. Oh, look, they have the functional if here. This is the return value. Right. It's one of these three things. Love it. This looks so much better now than JavaScript, regular JavaScript. I should close that thing that's making noise. I don't know if you guys hear it. Okay, close. Svelte looks super nice. It does not seem to be bloated. Yeah, I know nothing about it except when I read it. I just remember thinking, oh, just like the vibe and when they talk, like it's clear to me. You know, like I swear, like if I read React here. Let's learn it. Like, where? Is this it? Am I in? Oh, this is quick start. Reactor made of components. Oh my god. What is this? What is this? I'm returning HTML? Is this some kind of metaprogramming stuff? Like, why am I writing XML in here? Oh my god. Got, like, literally my heart rate and pulse, like, that is pissing me off already. I'm, like, getting pissed off. That's pissing me off. What is that garbage? What do we want? Tutorial? Oh, already. Doesn't this feel better? I just feel happier already. There's no. All right, so what do we do? Where's next? Welcome to this will teach you everything. You can also consult the API docs. Hacking your looks, create a project, right? Which this tutorial, or you can add in how to use this. Have basic familiarity, basics felt. Each section will present an exercise. Oh, I'm supposed to solve it. So what's the exercise here? Okay, now I'm getting mad. Oh, next. Here we go. I was just an idiot. I didn't click on the button. Adding component just renders. First add a script tag to your component, declare a name. So I'm here, right? No, we're not gonna do svelte. We're not doing svelte. We're not. We gotta stay on course. Help me. Then we can refer to name in the markup. Like, I don't know. Is it all in my mind, or does this feel like a million times better already? All right. Anyway, I'm sold. Like, it just. Yeah, I don't know. I mean, Elm's supposed to be really good too, but I don't think it's really being as supported right now. Like, it sounds like the community is a little bit lost, so. And maybe it's like the old style of doing things. Personally, I would use Live View for everything with Elixir, Phoenix Live View, but people want like really fancy UX, so yeah, right. It's the drama. It's too bad. But I think Live View is still very, very strong. It's really, I think it's a very solid answer if you can be like lenient on your UI UX needs. Just a little bit. Like there's so many people like when you work in a company, sometimes you get like a product owner or a designer that needs every pixel and animation to be exactly like this. And like that's going to be hard, but if you're building your own thing or like you got a two-way conversation with those people, then I think live view can work really, really well. All right, so here we go. Ugh. So what are we doing with non-literal types? So we have, yeah, so I don't need to test this. I totally get it. It's just saying like you can make things that combine you have a type here that takes in an interface or a literal type auto. Just makes sense. There's one more kind of literal type, Boolean literals. There are only two Boolean literal types, as you might guess. It's kind of funny to say like, this only takes in true, but you know. I get it now. That's why this language is Turing complete. The type system is Turing complete because you can say things like it takes in true and oh my god, this could be really powerful. It's very convoluted, but it could be, yeah, you could write a whole program just with types. How crazy is that? All right. The type boolean itself is actually just an alias for the union true or false. Literal inference. When you initialize a variable with an object, TypeScript assumes that the properties of that object might change values later. When you initialize a variable, yeah. For example, if you wrote code like this, where you have a counter is 0, some condition, counter equals 1. TypeScript doesn't assume the assignment of 1 to a field. Right, so are you saying that if I take in a literal, it wouldn't? Yeah, I think I get that. This applies to strings also. We have a function that takes in a method, like a URL and a method, returns void. Okay, this is good to note. Please answer this question. What's the difference between undefined and void? Why do I have another type now? So there was like undefined. Now we just learned about void. And what was the other one? There was another one I thought I saw. All right, see you later. Have fun getting groceries. Thank you. I'm going to stop soon anyway. You won't miss much, don't worry. Because we're almost at the end of the chapter. Thank you for joining me. That was a lot of fun just chatting. I swear there was another type other than undefined that we saw. Ah, null. It's right here later. Why are there so many different types for that? All right. So we turned void here. In the above example, request.method is inferred to be string, not get. Right. Oh, this is what we did before, I think. Something similar because of my book code here. This is what they're talking about here. It's inferred to be string, not get, because code can be evaluated between the creation of rec and the call of handle request. There are two ways you could change it, but type assert. This is exactly what we did. Oh, they did it as get. Aha. That's not what we did. So what they're saying here, this is bad, and I do as. But then what do I do it as? Oh my god, I have to type the string again. Or I could say, holy shit. This is stupid. Look at that. So this is the type. It's the literal type. We're just describing it twice. I really like what I did instead, which was just to do type book. This is a hard thing to write down here, but I guess I should just write it down in here. Sorry, I'll like try not to sneeze. Literal type inference, right? Is that what it was called? Literal inference. TypeScript will infer all literal strings to be strings and not the literal string type. I don't think I'll understand that when I read that again later, but I should just maybe copy this code. Maybe make it easier, just there's no point to make it like this. Yeah, we should make an easier one. Let's just do print book name, book names. And then we do okay, this is the same error. But if I did this as book name, let's see if this works. That solved it. So this is a workaround. Or let's list the 3 ways to fix this. So this is broken. Infers to string. Book names here. That one works. Now is the literal string. Literal type, string type? I don't know what to say. Literal string type. And then the other way to do it what is this action called again? It's called type assertion. And then the last way was to make it a const, which is a lot better also. Huh? Oh, and that's good too. I don't know what they called that. All right, so this will be our code in our little. Oh God. Type assertions. Little type inference. Here we go. Oh, I shouldn't have the let there commented out. Broke it. Okay, so we learned about literal type inference. This is something that I think you would just fix normally, like when you run into it, but I'll just write it down in here. I think on the stream it should have this information, right? Like, yeah, in the description it has the gist URL, so you can find it in case it's useful for you. Oh, it's not in Twitch though. So I'll just copy this into chat just in case anybody wants it. There you go. It should be in there. Yep. We're probably almost done with this section. Yeah, we're getting close. Null and undefined. JavaScript has two primitive values used to signal absent or uninitialized value. Null and undefined. JavaScript has two corresponding types by the same names. TypeScript. How do these types behave depends on whether you have the strict null checks option on. Oh God. Strict null checks off. With strict null checks off, values that might be null or undefined can still be accessed normally, and the values null and undefined can be assigned to a property of any type. This is similar to how languages without null check behave. The lack of checking for these values tend to be a major source of bugs. We always recommend people turn strict null checks on. So when it's on, when a value is null or undefined, you'll need to test for those values before using methods. Just like checking for undefined before using an option, we can use narrowing to check for values that might be null. Okay? Isn't there some kind of type that's just like a wrapper that says it's null, like possibly null, maybe null? So you don't have to type string or null? Anyway, alright, so we have to check for null, and we use equals equals equals. Why can't we use equal equal when we're checking for null? Non-null assertion postfix. Also, TypeScript also has a special syntax for removing null and undefined from a type without doing any explicit checking, with bang after any expression. Writing bang after any expression is effectively a type assertion that the value isn't null. So this is dangerous. It's saying here it might be null, but like any type of assertion, this doesn't change runtime behavior, so it's important only to use bang when you know the value can't be null. Alright, so what happens when it is null? So let's have a function that's like double, and it takes in a number. That's a number. Or it could be null, and it returns num times 2. Right, we have to do return. Why are you not happy? Possibly null. Was it like this? Afterwards. Alright, so this one's going to double, and then when I have, so now I'm going to make a number. It's 2, and I want to do double x. Four. And now what happens if this is null? There's no compile time error because we've told it I know better. Ah, how did it turn to 0? The fuck? So null turns into 0? Just checking in for a minute before I gotta run again. Hey there, how you doing, Charlie? Good to hear from you. I'm learning this for a contract that I think I'm getting, and they don't know I don't know this language, so I have to learn it real fast. Thank you. See ya. Okay, so it won't let me do that there. But look, it just made 2050 anyway. Crazy, right? So null turns into 0. And now what happens if this was a string or null? I guess it turns into an empty string, right? How do you concatenate two strings? Is it like this? Hello, hello? Aye. Let's just put null in here directly. And just a 0. Even though it thinks it's a string, because null automatically with this plus operator. Is there a concatenate operator on a string? Yeah, there it is. Okay, hello, hello. Now I put in null. Aha, look at this. So this one, it can't do anything with because it's calling a function on a null property. and then it failed, so it gives an exception. I think that's an exception. I don't know what would really happen. So we kind of learned that what happens. This is not safe. That's the moral of the story is that this is not safe. The bag is not safe to use. Enums are a feature added to JavaScript by TypeScript, which allows for describing a value which could be one of a set of possible named constants. Isn't that like unions here? Unlike most TypeScript features, this is not a type level addition to JavaScript, but something added to the language at runtime. Because of this, it's a feature which you should know exists, but maybe hold off on using it unless you are sure. You can read more. Yeah, we need to know more about enums because enums are awesome. All right, great. I don't remember which language has this, but this feels like Java or C++, I forget. This is not the enum that I would love, but whatever. At least we have enums. What happened? Where were we? Here? Yeah. Less common primitives. It's worth mentioning the rest of the primitives in JavaScript which are represented in the type system. I should probably just write a little note on enums here. Okay. Big int. So there is a thing that's not number. How big is big int? Wait a minute. Arbitrarily large integers. Okay, so you don't know how much memory it takes because it could be literally very, very big. It's like a string. All right. So there is big int. Symbol. I see you can make a symbol from a name. I see symbols are basically like atoms in a lot of functional languages or symbols. They're just all unique, but it looks like they could hold a value. I guess. I'm going to write that down. So we have symbols. You just, what is a symbol type? It's called symbol. Type is symbol. And creation is like symbol foo. There's also big int. Type is big int. That covers the stuff we just saw. And then we're done. Let's just make sure we know how like a symbol works. Let's have something that takes in a symbol. Okay, so we have log symbol. Now we want to make a symbol. If we try to pass it a string, it's going to say it's not assignable to symbol. But if we make a symbol here, now it works. Symbol, oops, it says symbol foo. So I bet x1 is a symbol, x2 is a symbol. I want to know if they're the same, right? Is it 3 or 2? I don't know what the difference is. Sorry, I'm like really trying not to sneeze. Is same. So this should be false. But it should compile because they're both symbols, right? Alright, what I'm trying to do is get to literal symbols. Alright, so false. It says it's not the same, but if I do S1, S1, now it's true. Now I wanted to say this one only takes in a symbol that is symbol S1. How would I say that? Can I do this? To enable treating symbols as unique literals as a special type, unique symbol is available. Unique symbol is a subtype of symbol and are produced only from calling symbol or symbol for or from explicit. This type is only allowed on const declaration. Reference a unique symbol. You'll have to use the type of operator. What is this doing? I don't know how to do this. Yeah, I'm not seeing it. I don't see a way to basically make to like have a type that is a literal symbol. Oh. Here's how you do it. Oh, right. We can't do it here. Okay. So here is, I made a type that is specifically this S1 symbol. So you see like the first one has to be an S1, the other, and it can be, the other one can be any other symbol. So I can do like S2 is equal to symbol S2. And this, like no errors, right? When I run it, I should say false because S1 and S2 are not the same symbols. But if I try to put S2 here, you see that it gives me an error. It says it's not because it's not a unique one. Even if we made it unique, let's watch. All right, so now const type of S2 is not assignable to parameter of type of S1. There we go. So a type of something is on a const is a way to get a literal. This seems like a very contrived example, so maybe it's hard to follow, but I'm going to put it up on my gist for, where should I put it? I'll just put it under symbols, I guess. Did I make a literal symbol too? Yeah, that has to be a literal symbol. Yeah, I think that's as close as we could get. So, uh-oh. Where was I? Why are we not happy? There we go. So here we have symbols, and we're making a literal symbol here. It's a shitty example, but I think it works for what we're trying to do. Alright, I have a bunch of things. Well, that's perfect. We are done with the basics. Holy shit, wait. What? Where am I? Oh, everyday types is what we're finished with. And then we're going to do narrowing? I thought we already learned narrowing. Why is there like such a long section on narrowing? Ugh, God. Alright, narrowing. Then we do more on functions. Okay, so functions are going to have their own types. Generic functions. That's cool. Whatever. Object types. Generic object types. Type manipulation. Creating types from types. Oh, cool. This looks fun. Then we have classes. Yeah, it's ECMAScript 2015 that added the whole class stuff, so I assume that's when they added all the optional types, properties, and stuff like that. So we'll see how this is different from an interface and all that. Probably because they can have functions, right? Class heritage. Object-oriented programming. I haven't done that in a long time. Alright, wow, these are long sections. But we've made it through everyday type. So we're like 2 out of 1, 2 out of 3, 4, 5, 6, 7, 8. We're 2 out of 8. A quarter of the way through. Hopefully I feel better tomorrow. I gotta keep going on this, and I will see you all later. Thank you so much for joining me. If you enjoyed this, please do follow, subscribe, or whatever. And I will catch you later. Bye.